Welcome! This video demonstrates the training of an artificial agent. As the video indicates, the problem is about walking in tunnels, or more specifically, searching for a treasure. Later in the video, we will demonstrate how an agent's memory is updated from experience using reinforcement learning. The evolution of the memory will be illustrated graphically. In the treasure problem, there are 4 possible actions, one for each cardinal direction. The state is defined by 2 variables, x and y, a 2-dimensional position. The x position ranges from 0 to 8. The y position is between 0 and 3. The starting position is always at x equals 0 and y equals 1. If the agent moves to a trap, marked with a skull, it receives a severe negative reward. The small treasure gives 10 in reward, while the big treasure gives 100 in reward. The problem is surprisingly challenging. An agent quickly learns a misleading pattern that moving too far east is dangerous because of all the traps.
The method to solve the problem is Q-learning. Q-learning is about fitting a function Q. Once this function is learned, it can be evaluated for different actions in a given state. One aspect of Q-learning is action selection. There is a probability that action selection is random. If this probability is high, the policy is said to be explorative.
The frame on the left represents the environment. Red object denotes traps. This frame also displays information such as the number of elapsed episodes. The frame on the right shows the agent's memory. The 4 upper plots represent the Q function. For example, the white cell in the east action plot indicates a positive reward for moving into the small treasure. The value function is also shown. It represents the value of the best action in each state. At the bottom, the policy is illustrated. The arrows indicate the best action to take in each specific state. The policy shown here is not optimal. The agent training now begins. Here, the probability for random action selection is relatively low, 10%. Therefore, the action selection depends much on the Q function. Let us pause for a moment and reflect. The agent has learned that taking the east action, when positioned next to the small treasure, has a high value. This is indicated by the light gray cells, which represent positive values. Now we speed up the animation to fast-forward evolution. As you can see, the agent memory is further updated. The training is now finished. The result is an agent that has learned to find the small treasure. This training was a disappointment. The policy was suboptimal because it expresses how to find the small treasure. Let us repeat the training, but with a higher probability for random action selection. This setting gives for the initial episodes almost completely random motion. Frequently, an episode terminates early because the agent easily moves into a trap. Now we speed up the animation. It is possible to see how the agent memory is further updated. A trained agent is now in place. Wonderful! This is fantastic! For these final episodes, we can observe the desired behavior. The big treasure is consistently found. The explorative behavior ensured that the agent was not stuck in a suboptimal policy. In reinforcement learning and in engineering in general, one must be aware of suboptimal solutions. The problem presented here is one of many example problems described in the book Reinforcement Learning Explained. This was only a brief description. Many more details are presented in the book. The book also presents additional techniques that speeds up training for the treasure problem. Please visit the book's homepage for more information.